Good afternoon. Good afternoon. Today I am going to go through the Western Cape paper from Metro North Education District, School-Based Assessment, September Trial Common Examination, Geography Paper 1, Task Number 6, September 2025. I'm going to go through this paper. I'll start with climate and weather. I'm not going to go over the instructions. I'll go straight to the paper. So I hope it will be visible enough for all of you to see. I'll try by all means to make sure that it's visible enough for all of you to see. So the question reads, various options are provided as possible answers to the following questions. Choose the answer and write only the letter A to do next to the question numbers 1.1.1 to 1.1.8 in the answer book, e.g. 1.1.9D. I read because I want to emphasize that following instructions is very important. That's why I read. I don't just go straight to the question. Following instruction is part of the examination. That's why I try also to read so that at least you know what is expected of you. So refer to the sketch below to answer questions 1.1.1 and to 1.1.5, which means you are going to use this sketch to answer 1.1.1 up to 1.1.5. So if you find yourself answering 1.1.6, 1.1.7 and 1.1.8 using the same sketch, you are likely to get wrong answers. So make sure you are attentive to detail. Make sure that you read the instruction. This has been given as an instruction, as a directive to say that you are only using this sketch to answer question 1.1.1 up to 1.1.5. Okay, before I start answering the question, I think there's something that I want to train you. I want you to, the moment you get a picture, the moment you get a sketch, try to analyze it, to make sense of it before you even attempt to answer any questions. Try to make sense of it, to analyze it before you attempt to answer any question. Okay, so you can see what we have on our sketch. We have got high pressure in the interior, which is the H that we have here. So already what comes to your mind is, oh, of course, when we have higher pressure in the interior, it means that it's winter. That's what comes to your mind. You also look at the position of your high pressure system, your South Atlantic high, then you've got your South Indian high. Look at their position. They have moved further north. They are further north. This is the position that you find them, especially during winter. They migrated further north because our ITCZ was on top of the equator. Okay, then we have got our H here, which is the Kalahari High. So during this time in winter, there's too much subsidence. Within the interior. That's why we have got our Kalahari is very active. There's a lot of sinking air coming from the continent, okay, within the interior. That's what is happening. So once we have an idea of exactly, it will be easier for you to identify the season as well. You can see, okay, clear skies. You can see here the cloud cover is clear skies. You can see also the temperatures which are high, the temperature range between the high and lower temperature. You can also see the difference in temperature. It also helps you to analyze whether it's winter or it's summer. So in this instance, we are saying now, because there is H in the interior, whenever you see H in the interior, it tells you that it's winter. Let's go to a question. The synoptic weather map represents what conditions are represented by this synoptic weather map. You can see, like I've already said, there is H, which is high pressure. So from the options that we have, autumn, spring, summer, and so your answer here is what? Is winter. This is when we have got our Kalahari High in the interior where it's more active. This is when we have got clear skies, as you can see. This is when we look at the position of our high pressure system, that your South Atlantic High and the South Indian High, they have shifted in terms of their position. They have moved further north. So the answer there is what? Winter. Let's move on to the next one. The low wind speed recorded at Bloemfontein on the synoptic weather map is caused by. So when it comes to the wind speed, of course, the concept that should come to your mind is your pressure gradient. When you talk about the wind speed, is your pressure gradient. So it means where we have got a high wind speed, there is steeper pressure gradient. Where we have got low wind speed, obviously there is weaker pressure gradient. So when you talk about pressure gradient, okay, when you talk about wind speed, it's pressure gradient. When you talk about wind direction, what comes to your mind is your Coriolis force. This is your Coriolis force. When you talk about the wind direction, obviously in your northern hemisphere, the wind are deflected to the right. In the southern hemisphere, they are deflected to the left. But here the concept that we are trying to explore is your pressure gradient. Why? Because it's what determines the wind speed, whether we have got stronger winds or weaker winds. So let's see from the option that we have. So obviously it's low wind speed, which means it's a weak pressure gradient. The answer there is B. The air pressure reading at A is, you know, the isobaric interval is 4 millibytes or 4 millibytes, or it is millibars, or it's 4 hectopascals. So from here, if you check 1024 hectopascals, 1020, which means the next one will give you 1016, which means here you are likely to have 1016. That's what you're likely to. So because the isobaric interval is 4 hectopascals. Okay, so here it means you're coming from high pressure, which means the high pressure is high towards the center, but as you move away from the center, the pressure decreases. So here is 1024, here now it's 20, here is 16. So the answer there is A. So you should know the isobaric interval is 4 hectopascals or 4 MBs. Okay, let's move on to the next one. The next question reads, the dew point temperature indicated at weather station B is. Okay, let's go to weather station B. We want to find the dew point temperature. Okay, weather station B, what do we have? This is the weather station B that is being pointed at. So this is atmospheric temperature, which is always the highest one. This is the minimum, which is your dew point temperature. So you can see there it's 1. You can see this one. Let's go to our options. Okay. What is the correct answer? There is 1 degree, which is C. Then the interior of South African experience conditions with a greater temperature variation due to dash climatic conditions. So what is happening in the interior during this time? What is happening during this time? Okay, what is happening during this time now? Let's go back to the question. This is winter. So there are stable weather conditions here. Okay, they are stable weather conditions in the interior. Obviously, our air is moving, okay, our wind is blowing from the continent towards the coast. So that makes it continental. Remember about air masses from grade 11, he said a large body of air that has got similar characteristics in terms of temperature and moisture content. That's what an air mass is. So it's emanating from the continent, blowing towards the sea. That's what makes it continental. And in the interior is stable. Why? Because of the clear skies that we are seeing. Let's go back to the question. So here, the interior of South Africa experience obviously is going to be stable. Why? Because of the clear skies that you have seen there. It's going to be stable. Then where a greater temperature variation due to, of course, is continental, because it's coming from the continent and blowing towards the coast. So which is 2 and that is number 1.1.5. 1.1.5 is 2 and 3 in Roman numerals, which is our D. That is your answer, because the wind is blowing from the interior, is emanating from the continent. It is the source of the air mass from the continent blowing towards the coast. In the interior, there are stable weather conditions. That's why there are clear skies. That's why we've got this as our answer. Let's move on to, remember, the instruction says, I'll go back to the instruction, refer to the sketch below to questions 1.1 to 1.5. So we have now answered 1.1.1 to 1.1.5. Let's move on to the next one. So it means now, for this question, which is 1.1.6, we are going to use the instruction again. Refer to the map below to answer the question 1.1.6 to 1.1.8. This is the instruction. So it means from now onwards, we are using this sketch now. What do we have now? The low pressure cell in the sketch is, before we do that, like I have already highlighted, let's try to analyze this sketch before we start doing anything. Okay, what you can see that there is low pressure in the interior, number 1. Number 2, can you check the position of your high pressure system? They have moved further south. South Atlantic high, South Indian high. They have moved further south. We suggest already that this is in summer. You can see also the overcast that is within the interior. That is where we receive most of our rainfall, in the interior. That is in summer. So this helps you to know the season. Okay, so L, it shows that it's summer. H, it shows that it's winter. So here, this is within the summer. You can see position of our high pressure system. They've moved further south, which means our ITCZ is on the south of the equator. Okay, what do we have? The low pressure cell in the sketch is, this is your thermal low. This is your thermal low. This is your thermal low. When you talk about your coastal low, of course, it's during the winter. During winter, that's where you've got your coastal low here. Okay, but this one is in the interior. The low pressure is not at the coast. So this is your thermal low. The tropical cyclone and the tropical depression, of course, that one, of course, is not related to this. Okay, let's move on to the next question. The feature B is known as feature B. Let's go to feature B. Feature B. Okay, we have got high pressure. We have got high pressure. In between, that is your saddle. That is your saddle. Okay, that is your saddle. Okay, that is your saddle, which is D. Then from there, the low pressure cell over the interior is caused northwesterly winds because of, obviously, when you talk about the low pressure in the southern hemisphere, it moves in a clockwise direction. Your low pressure in the southern hemisphere, we are referring to this. This is your low pressure in the southern hemisphere. It moves in a clockwise direction. It is the high pressure that moves in an anti-clockwise direction. So there we have got clockwise direction, which means this one is out. Then obviously when you talk about the low pressure, it is associated with warm air. What does warm air do? It ascends, it does not descend. So warm air, what does it do? It rises because it is light. As it is rising, it cools, reaches the condensation, clouds form, then we have got rainfall. So the options that you have here is 1 and 4. Is 1 and 4. 1.1.8, 1 and 4, which means your answer here is what? Is C. Let's move on to the next question. Let's move on to the next question. Let's move on to the next question. 1.2. Refer to the sketch below showing valley climates. Okay, the concept that is being explored here is your valley climates. What comes to your mind is microclimates, urban climate. Okay, valley climates. Okay, let me just say microclimates. Okay, I don't want to confuse you. Microclimates, of which urban climates is part of also microclimates. So obviously the concept that should come to your mind is your thermal belt. Think about the radiation fog. Think about the katabatic wind. Okay, think about the anabatic wind. What else can you think of? You can think of frost sprocket. I think you can think about your aspect. Whenever you hear the word valley climates, okay, those concepts should actually come to your mind. You should also start thinking about those concepts. These are the questions that I'm likely to be asked about. Complete the statement in column A with the options in column B. Write only Y and Z next to the question numbers. This is what we have. Let's go through the question. So when you're looking at this diagram, what do you have? You have got this wind that is descending. So what should come to your mind already is cold. It's even written cold plateau. Okay, you can see cold air draining. You can also see in terms of the temperatures, minus 2.8 degrees. You can see the temperatures is higher than what is at the valley bottom. Okay, you can see also the shadow zone. So when you see the shadow zone, what is coming to your mind is the point of aspect. Okay, aspect, that's what comes to your mind. Okay, so now that you have got all that in your mind, okay, let's get to the question now. What is the question saying now? The direction in which the slope faces in relation to the insolation, which is your incoming solar radiation, that is your insolation. Obviously, we are talking about the aspect. We are talking about the aspect, which is Z. Then, the sketch represents a valley in them. Okay, this is a valley that we have here. Where is this valley? Where is this valley? Okay, what happens when it comes to valley? We're talking about the aspect north-facing slope. They receive direct insolation. Okay, which means north-facing slope, they are in there. Okay, they receive incoming solar radiation, and the south-facing slope, they are in the shadow zone. But if you look at this now, you would find that is the way they've made it is more like it's the opposite, because the shadow zone is supposed to be in the south-facing slope, which does not receive a lot of sunlight. That's what it's all about. So north-facing slope, they receive more direct sunlight as compared to the south-facing slope. So 1.2.2, we are saying now is southern. Okay, the sketch represents a valley in the southern hemisphere. Then 1.2.3, winds develop due to terrestrial radiation. What comes to your mind now? Which winds develop due to terrestrial radiation? Something to do with, okay, that is your katabatic, which is what is being shown here. Then a temperature inversion occurs between A and B due to N. Okay, 1.2.4, there is an increase of the temperature with an increase in height. That's where you've got your temperature inversion, the increase in temperature, the increase in height. Okay, under normal circumstances, the temperature drops with an increase in height. Okay, but when it increases with the increase in height, that's what we call temperature inversion. Then the form of precipitation that could form at X, here at X. Remember, the temperature is below 0 degrees. That's when we have got our frost. So there, 0 degrees, that's where we have got our frost. Okay, then what we have, fog may form in the valley on clear calm nights. Of course, that's your radiation fog. That's your radiation fog that develops during that time. An area where warm air mass is trapped between cold air masses, that will be your thermal belt. We are saying now there's cold air here, there's cold air at the top, then we have got warm air in between. That's how you get your thermal belt. So it's trapped between two parcels of cold air, which means cold air at the top and cold air at the bottom as well. So that will be your thermal belt. Let's move on to the next one. Let's move on to the next question. This one reads, I'm going to read, refer to the extract of synoptic weather map on mid-latitudes, okay? Mid-latitudes, okay? Before I attempt to answer this question, I just want to highlight one or two things just to make your life easier. I've come up with this diagram about our global air circulation. This is what is going to help you to understand. You never forget, where and also how these mid-latitudes or tropical cyclones are formed. Okay, so the first thing that you need to know is you should have an idea of this. Where is your easterlies situated and where is your westerlies situated? Okay, this is going to make your life easier. So here we have got low pressure at the ITCZ, here where we have got our L. This is your ITCZ. It is also the equatorial low pressure is a zone of low pressure. This is where air masses converge because of low pressure. Okay, when they converge, okay, this is where we have got high pressure, which is your subtropical high, where we have got H both north and south of the equator. This is where we have got the subpolar low, where we have got L both north and south of the equator. That's where we've got the subpolar low. This is where we have got the polar high. So if you know the pressure, high pressure, the pressure system, the pressure system, okay, then you won't have any problem. So this is where you have got your polar high, subpolar low, subtropical high, equatorial low, low pressure, subtropical high, subpolar low, polar high, both north and south of the equator. So where do we have the easterlies? The easterlies is between subtropical high and your equatorial low. So this is where you have got your tropical easterlies. Also same north and south of the equator, you've got your tropical easterlies. Where do you have your tropical westerlies? Of course, your westerlies, you have got them between 30 degrees north and south of the equator. This is where you've got your westerlies, because your high pressure is moving from here, is going towards the low pressure, and from here is going towards the low pressure as well. So this is where you've got your westerlies between 30 degrees north and south of the equator. Then you also have your polar easterlies. That is from 60 degrees to 90 degrees north and south of the equator. That's where you've got your polar easterlies. So the reason why I'm doing this, because at some point you'll be asked, why is the mid-latitude move? What is the direction in which the mid-latitude move? You should be able to know what drives the mid-latitude, what drives the tropical cyclones. Okay, so when we talk about the mid-latitude, we are concerned about this area, in the middle of the latitude. So they are taking place from 30 degrees north to 30 degrees south to 60 degrees south. This is where we have got our mid-latitude, both north and south of the equator. So what drives them? Here we have got the cold air from the polar high. Okay, then you've got the warm air from the subtropical high. They are separated by a polar front that you find at the subpolar low. So you've got cold, you've got warm. So what drives them? They are taking place, okay, they are taking place within 30 degrees north and south and 60 degrees south. So this is where we have got our mid-latitude. So they are driven by the westerlies and they move from west to east, or they move eastwards. That's what we mean when we say they move from west to east, which means they are moving from there towards that direction. So they are driven by the westerlies, they move from west to east. That's where we have got our mid-latitude. Let's go to the question now. Wet cold weather expected to continue in Western Cape, Wednesday, August 20, 2025, okay? A series of cold fronts are still on track to make landfall, okay? On track to make landfall, resulting in weak and cold conditions. The coldest daytime temperatures will be on Wednesday, August 20, and next cold front will rain is expected to arrive on Thursday. The city of Cape Town, Overberg, Cape Winelands, and West Coast districts will be hit by the hardest by the severe weather. Cape Townians can expect rain for 3 days of this coming week, with downpours falling on Wednesday and Thursday. Between 10 to 20 millimeters of rain is expected over the Western Pass. Between 40 and 60 millimeters will be expected over the southern Western Mountain. The Provincial Disaster Management Center is monitoring the situation. So already what they've done here is they've given you this I would say infographic. Of course, you've got your synoptic weather map, you've got the other information, of course, that's part of your infographic. Okay, so what do you have from this extract? You have got number one, there is the date that you can see there. You also have every information that you're going to use. There's the cold front, as you can see. There's the cold front approaching, the date is there. You also have your mountains. Of course, you also have this information that have been given to you. So the first question reads, state the general direction of movement of the mid-latitude cyclone. You can see it's moving from here going towards this direction, which means from west to east. It's moving eastwards. I've also shown you from this diagram that they are influenced by the westerlies, which means they move from west to east. So the correct answer there is eastwards. They move in from west to east or eastwards. That's the direction that they move, from west to east or eastwards. Okay, give a reason for the direction of the movement of mid-latitude. Remember, I said mid-latitude, they're happening between 30 degrees to 60 degrees south, which means they are driven by the westerlies. That will be the reason. The mid-latitude cyclone is steered by the westerlies, or the cyclone occurs in the westerly wind belt, okay, from here going towards that direction. That's what is happening. Then draw a labeled cross-section from B to C. Okay, what we have from B to C? From B to C, what we have? Okay, I'm going to draw. Okay, this is from B to C. What do we have? I want to show you what we have here. From B to C, I'll be drawing by the side. Okay, so from B to C, we have got, I'll take this as the cold front. What do we have? Okay, or before I draw, let me just go read the whole question. Indicate the following on the cross-section. Indicate the following on the cross-section: the cold front, the cold sector, and the movement of warm air. All right. So this is what we have. This is from B to C. B to C, as you can see. So here, what we have here, we have got the cold front. This is what I've done, the cold front. And behind the cold front, what we have? We have cold air. We have cold air. Here, this is part of our warm sector. We have got warm air. What is it doing? It's rising. Warm air. We have got warm air. What do we have? Warm air is light, so which means this warm air, cold air is what causes this warm air in the warm sector to rise. So you've got your cold air, you've got your warm air, indicate that is rising. Then you also have your cold front. So this is the cross-section from B to C. You have cold air here. You can see there's a steeper pressure gradient, there's a cold front, there you've got your warm sector, where you've got just after, in front of the cold front. So this is what you're likely to have. You've got your mark here, 1, 2, 3. That will be 3 marks. So 1 mark is correct indication of cold front, correct indication of cold sector, where you've got your cold air, then correct indication of the movement of the air, then you get your 3 marks. Okay, 1.3.4. A group of tourists like to attempt to the hiking trail to the top of the Table Mountain on the same day that a cold front is expected to arrive. So this is a scenario that you are given. Please bear it in mind. This is a scenario that you have been given. So it means your answer is going to be based on this quotation, on this scenario that you have been given. In a paragraph, approximately 8 lines, this is a paragraph question, of course, is expected to be written in form of a paragraph, not in point form. Discuss the different weather conditions and the possible impacts to warn the organizers why the hike must be postponed. So your question is in 2 parts. Number 1, weather conditions. Okay, you are discussing the different weather conditions that are likely to take place. Then once you have highlighted the weather conditions, you move on to look at the possible impacts to warn. So it's in 2 parts. What are the likely weather conditions? Number 1, we are likely to have heavy rainfalls or thunderstorms. That's number 1. We are likely to have lightning. We are likely to have hail. The temperatures are likely to drop. We are likely to have snow. We are likely to have strong gust winds. We are likely to have overcast conditions and cumulonimbus clouds. We are likely to have front of fog and mist. These are the weather conditions that we are likely to have. Remember, it's 4/2, which means you try by all means to make sure that from the answer that you're going to write in form of a paragraph, if you can have 3 points talking about the weather conditions, make sure you have another one talking about the impacts that is different. That you are looking at the impacts, or you can say 2-2 or 3-1 or 1-3, whichever way you will do it. But make sure that you look at both sides. So we are now looking at the possible impacts. We are looking at the slippery and dangerous trail condition that can be an impact. You are warning them, remember. Possible injury from lightning strikes. Hail may injure hikers and make the route unsafe. Discomfort due to cold temperatures. Dangerous trail conditions from snow, among other reasons. So we have looked at both. And remember, when you are answering a paragraph question, you state the fact, then you qualify the fact, which means the point is supposed to be fully explained. That's what it means. When we said the fact and the qualifier, you are supposed to explain it in full. So I have interpreted the question. That is in 2 parts. You write the different weather condition and also the possible impacts. Remember, you are warning the organizer why the hike must be postponed. So once you have highlighted this, try to link it as much as possible to the requirements of the question. Let's move on to the next question. We are now moving on to 1.4.5. It reads, refer to the infographic of the tropical cyclone Judy. Tropical cyclone Judy. So whenever you hear about the tropical cyclone, what should come to your mind, guys, is tropical cyclones, they are named alphabetically, which means if you have got Judy here, the assumption is we have already have how many? A, B, C, D, E, F, G, H, I, J. You see the way we are counting now, which means we have had about most like 10. A, B, C, D, E, F, G, H, I, J, which means we have had about 9. There is 9 before J alphabetically. So it means they are named what? Alphabetically. So you should know that. Okay, let's go through the question. Okay, this is the movement of the tropical cyclone, of course. So when you talk about the tropical cyclone now, let's come here. Is between 0 to 30 degrees south. So which means it moves from east to west. Okay, it's driven by the easterlies. This is where we have got our tropical easterlies. This is your tropical cyclone now. I'm talking about tropical cyclone in the southern hemisphere. So it moves from here, from 5 degrees south, because from 0 to 5 there is a lack of Coriolis force which affect wind direction. So it starts moving from 5 degrees until it reaches 30 degrees south. That's when it starts to move in this direction. You understand? Okay. So it moves, okay, from here. Of course, it's more like in a southwesterly direction. Of course, it moves like from here where it's coming from. This is northeast towards the southwesterly direction. It's moving from here. It's driven by the tropical easterlies, okay, from east to west. When it reaches 30 degrees south, that's when it starts to move in this direction now. That's where it starts to move in this direction. So let's go to the question. It reads, okay, we have got this diagram. This information that is given here, the formation, how is it formed, the tracking and the impacts of the Mozambican tropical cyclone, impacts on Mozambique. So use this information, guys. You go through this information. Do not just rush to answer the question. Let's do it together. Disturbance was upgraded to the disturbance was upgraded to tropical depression on 7 March and tropical storm Jude on 8 March. Reached tropical cyclone strength on 9 March before making landfall in Mozambique, of course. Which means the tropical cyclone, where it started, now it has been upgraded. You can see now it's gaining momentum. That's what it's talking about. It gains momentum, which means it's even more destructive than what it was when it started. That's basically what it's all about. Okay, then tracking 10 March. That is the use of GIS now in tracking tropical cyclones. Landfall in Mozambique, strong winds with heavy rainfall. Tracking, of course, they're tracking the weather conditions, which means they comment on the weather conditions. What are the impacts? Negative, okay, and also how destructive it is as it is moving. So that's what this is all about. I'm going to read everything. Then the impacts. What are the impacts now? It has affected how many people? 375,214 people affected. 81,149 houses damaged. So these are the impacts, of course. So this is going to help you now when you are answering the question. I'm not going to read everything. Severe flooding affected infrastructure, crops. So when you are looking now in exploiting a concept, okay, tropical cyclone, how are they formed? That's formation. How do they move? Of course, part of the tracking, we use GIS to track them. Then also, what are the impacts? What are the problems? And also, we're supposed to come up with strategies. Let's go through the answers now. The question, give one evidence from the infographic that the tropical cyclone occurred in the southern hemisphere. You can see these countries are in the southern hemisphere. Madagascar, Mozambique, it's a map of southern Africa, southwesterly movement, what else located over the South Indian Ocean. So all that actually substantiate the notion that is within the southern hemisphere. So all those things are answers to the question, but you can only use one. From the infographic, name 2 weather conditions associated with tropical cyclones. Okay, what are the weather conditions associated with tropical cyclones? You can also see here, guys, everything is here. Everything is here, guys. What do we have here? Let's say what you can have. Of course, we are talking about strong winds. The strong winds, I think you can see it has been upgraded. Strong winds, this is strong winds we have here. We also have rainfall, which means you have answered, you have got your 2 points there. Let's move on to the next question. Then from there, you move on to 1.4.3. Account for the direction of the tropical cyclone Judy. Okay, 1.4.3, in what direction does it move? Tropical cyclone moves from east to west and is steered by the easterlies. Okay, here is where we have got our tropical cyclone from 0 degrees, okay, from this, okay, I would say 5 degrees south to 30 degrees, okay. So it is driven by the tropical easterlies, so it moves from east to west. That's how it moves. This is where you've got our tropical cyclones in the southern hemisphere. So it's moved from east to west, is steered by the easterlies, okay. Then 1.4.4. Explain the increase in wind speed from tropical cyclone Judy on 9 to 10 June 2025. 1.4.4. Obviously, what are some of the conditions that actually that are conducive for the development of the tropical cyclone? We are looking at things like the movement over the warm Mozambican channel. Obviously, it's a warm ocean, which means there's more evaporation taking place there. There's more evaporation that is taking place, which results in more moisture available. When condensation takes place from that warm air that is rising, there's a release of latent heat. These are some of the things that is happening in order to increase the speed, the wind speed within the Mozambican channel. Less friction over the warm Mozambican channel, high temperatures, remember, it's closer to the equator, of course, the higher temperatures, the warm oceans, increased condensation results in the release of latent heat. Latent heat drives the system and increases the wind speed. So those are some of the things that you can actually talk about. Describe the negative impact of tropical cyclone Judy on the physical environment. We are talking about the natural environment. That's what we are referring to as the physical, natural, on the coastline of Mozambique. What are some of the negative impact on the physical environment? 1.4.5. We are talking about the coastal erosion will take place, obviously, because we are likely to have what? We are likely to have floods. So this will result in erosion. So erosion will occur on the land. Why? Because you've got heavy rainfall there, mass movement, change the landscape, reshaping of the coastline, the habitats will be destroyed, okay? Food chains, wood webs will be destroyed, biodiversity will be diminished, silting of rivers because of soil erosion. Of course, the soil is carried to the river, which results in silting of rivers, increasing leaching of nutrients. These are some of the things that you can talk about. Remember, the comment is on the natural environment, which is the physical environment. Then 1.4.6 suggests 2 strategies to reduce the impact of future tropical cyclone. 1.4.6, what are some of the strategies that we can actually use to make sure that we reduce the impacts, okay? What are some of the strategies that we can actually use to make sure that we reduce the impact? We are on 1.4.6. What can we do? Early warning system has to put in place, awareness and education programs, evacuation protocols and drills. We can stock up for emergency supplies and necessities, identify high-lying areas to evacuate people. What can we do? Build above floodplains or coastal zoning, tracking the movement of the tropical cyclone, move people to higher ground. There's a lot that we can actually do, but these are some of the things that you can actually recommend as strategies. What you have seen now, we explore the concept. explain how it is formed, we identify the problems, then after identifying the problems, we're supposed to come up with solution. That's what we do in geography. We do not just explain the concept, we do not just identify the problem, but we also come up with solution. Let's move on to refer to the infographic below on Berg winds. What we have here when it comes to Berg winds, obviously the season, you know that it's what? The season is winter. Okay, you have got high pressure system. Remember, we've talked about this. We have a coastal low at the coast. So that tells you that is what? It's the Berg winds. You can see also with the weather conditions here, what we have, clear skies here, obviously because the wind is blowing from the interior, which makes it an offshore wind. It's warm and dry. It does not carry any moisture with it. It's warm and dry. That's why when it gets to X, it's warm and dry. There is no rainfall that we get. Why? Because it's warm and dry. It's coming from the interior towards the coast. Okay, then what else do we have? The temperature, and also you can also the time. All right, Berg winds conditions that are favorable to runaway. Fires are expected across the east coast on Tuesday, the South African Weather Service said. Forecaster Quinton Jacobs said these conditions will persist until Thursday. Berg winds conditions with temperatures in the high 30s are expected for next 3 days. A strong northeasterly flow is expected over the northern interior of Wednesday during the mid-morning and early afternoon, exceeding 40 kilometers per hour time. According to the Weather Bureau, with the recent fine weather and the absence of rainfall, the already dry vegetation would further dry out and conditions favorable for the spread of runaway fires will develop. Okay, then the first question reads, identify the season depicted on the map. Obviously, we have got H here in the interior. That shows you that is what? It's the winter season. That's when we have got our Berg winds, is the winter season. Then name the high pressure cell and the low pressure identified. So here we have got the Kalahari high. H, we have got the Kalahari high. Kalahari high. Then here we have got the what? We have got the coastal low. This is the high pressure. This is the low pressure, the coastal low. That's what we have there. That is for 1.5.2. Let's move on to the next one. Then here what we have, with reference to the graph, explain the temperature increase from 0315 to 10 o'clock. Okay, 1.5.3. Explain the temperature increase. Why do we have that temperature increase? Of course, it's moving from the interior down the mountain. It's adiabatically warmed, which means for every decrease in temperature, every decrease in height, for every 100 meters, the temperature increased by 1 degree Celsius. That's what we call dry adiabatic lap rate or adiabatic warming. That's what is happening. So it undergoes heating caused the adiabatic process, which is adiabatic warming. It heats up by 100 degrees Celsius per 100 meters as it descends. So that is what is happening. So from the mountain, going down there from the interior, which means we are saying now as it is descending, it is adiabatically warmed, which means for every decrease in height of 100 meters, the temperature increased by 1 degree Celsius. That's basically what we are talking about. This decrease in height, which means the temperature increased by 1 degree Celsius. That is adiabatically warmed, okay? Which is what we call the dry adiabatic lap rate, okay? Give a reason for the cloudiest conditions on X on the map 1.5.4. Air descending the escarpment is an offshore wind, hence dry. Descending air heats up, resulting in no condensation, or that is formation of clouds. Descending air heats up and remaining moisture is evaporated. That's what is happening, which means as this air is descending, it's also losing moisture. There's evaporation that is taking place. Whatever moisture is left with this descending air is evaporated, okay, is lost through adiabatic warming, okay, because as it is descending, the temperature increased by 1 degree with a decrease in 100 meters, okay, that's what is happening. Then 1.5.5, why is the threat of wildfires greater during the day when the Berg wind conditions, okay, 1.5.5, higher temperature, higher air temperatures during the day, the greater amount of evaporation and dries out vegetation during the day as well, low relative humidity, increase the possibility of wildfires and more human activities, okay, that's what is happening, that's why it is high. 1.5.6, discuss the negative impact of Berg winds on the natural environment. What are the negative impact of the Berg winds on the natural environment? 1.5.6, we have got dry conditions. Obviously, it can result in the wilting of some of the vegetation. Higher temperatures, the strong winds, increased evaporation. So all that, it also negatively affects the natural vegetation. So these are some of the things that you can talk about. The dry winds, high temperatures, strong winds, and increased evaporation. So this takes us to the end of our climate and weather. for our Western Cape paper. That is the paper for the prelims for September. Okay, thank you so much.